Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to talk about finding the derivative of a function at a point. You should be familiar with the actual definition of the derivative at a point. And so we're going to use that definition, either of these two. There's two different versions of it. We'll use either of them to find the derivative of the function from a previous example at the point x equals 1. And actually, we might as well just do that for other points as well. Now this example, 2.7 number 1, is just a couple pages back, but it looks like this. And I might as well just do the whole problem. Maybe I'll just do it at x equals 1 just to showcase it. But the function was this, x minus x cubed. And we want to find the derivative of that function at 1. Well, that just means that they're asking for f prime at 1. So let's go ahead and write that down. F prime at 1. And we know that's one of two things. Either the limit as x approaches 1 of f of x minus f of 1 over x minus 1, or you could use the alternative definition, I'll just write it over here in green, the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. That 1 plus h just says you're standing at 1 and we're going to wiggle slightly away from it. And we're going to allow that wiggle to get smaller and smaller and smaller so these 2 points get dragged together. Now we've already done this problem. So I recommend that you go to the previous videos in this series to see how I arrive at the following, where I'm going to say this is -2. But just to showcase the mathematics, I'm going to do something slightly different. Let's investigate the derivative at a different point. Specifically, let's go ahead and investigate the derivative at, let's say, I don't really care. Let's go to 2. So f prime at 2. Well, again, that limit will be as x approaches now 2, and we have two options. And the first option being f of x minus f of 2 all over x minus 2. Obviously, direct substitution will not work there yet, but we could manipulate it. The other option, which I am going to write off to the side again because we might be using it, is the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Now, as I mentioned in the previous video, I often like the limit that's written there in green. I think it's just an easier limit to work with. But let's just see how this limit will work in black. So that'll be equal to the limit as x approaches 2. You cannot use direct substitution yet because it would cause division by 0. And I'll go ahead and copy f of x, so it's just x minus x cubed, and then subtract off f evaluated at 2. If you evaluate f at 2, that's 2 minus 8, so that's a -6. Let me just double check my math because I can be wrong. I'm not, but there you go. Now here's the problem. It's not much of a problem because you have prerequisite material that you have to enter into this course, but you end up with this polynomial in the numerator. And you still can't use direct substitution because if you tried to, you'd get division by 0. And, by the way, the numerator would be 0 as well. So this ends up being confounding to a lot of students. They don't like this to use this black ink method because they get stuck right here. By the way, I'm going to erase that and call that a 6 because it looks really weird. But I'm going to tell you, you can actually still do this problem. You happen to know from your prerequisite course that you can factor. Now, if we know that, so I'm going to write this down actually. We know from our pre-calculus prerequisite that if we know that we have a 0 at c, then x minus c must be a factor. Well, I can tell you right now, had I plugged 2 into this polynomial, or into this rational function, sorry, the denominator would be 0. So obviously 2 is a 0 of the denominator, but that's kind of obvious, honestly. And if you plug 2 in the numerator, you get 2 minus 8, which is negative 6, plus 6, and that's 0 as well. So 2 is a 0 of both the numerator and the denominator here. And therefore, our theorem, which is, by the way, called the Factor Theorem, tells us that x minus 2 must be a factor of that numerator. How do you factor that out? Synthetic division. You do synthetic division by the opposite of that, basically what would make x minus 2 0. So let me go ahead and write this. If 2 is a 0, then x minus 2 is a factor. So if x minus 2 is a factor, we can do long division or synthetic division to find out what this polynomial will become. So let's see, our lead coefficient is a negative 1. Leading coefficient is negative 1 on that x cubed. We have 0 x squareds, we have 1x, and we have a 6 for a constant. And now you just bring down the negative 1, multiply it by 2, you get negative 2, add, you get negative 2. 2 times a negative 2 is a negative 4. 1 plus a negative 4 is a negative 3. 2 times a negative 3 is a negative 6. And we knew it was going to happen because it's a factor, but there it is. We have a remainder of 0. And so therefore, and if you're kind of staring at this going, what the heck is he doing? You need to talk to your pre-calculus instructor and tell them to teach you this, because this is a required piece of information from pre-calculus. I also have a video on the factor theorem, the remainder theorem, all this stuff. So look in my pre-calculus video series and you will find how to do this using synthetic division to factor, all that stuff. So anyhow, this means that x minus 2 would factor out and we'd be left with a negative x squared minus 2x and minus 3. Of course, now we know that the x minus 2's will cancel brilliantly, and we can use direct substitution because there's no more division by 0 if we plug in 2. So direct substitution allows us to say this is going to be a negative 4 minus 4 more, so it's negative 8, minus 3 is a negative 11. Now, if you are too afraid to use the factor theorem and synthetic division, which I kind of don't blame you, if it's been a while, it is daunting, but I'm letting you know right now that that is an awesome technique, and you will have to know how to do that stuff if you're going to go through the entire calculus series and then into like differential equations. Being able to do something like that is critically important. You should do it. But let's pretend that you just didn't. You decide to do what I like to do, which is this theorem right here, or this version of the derivative at a point right here. So if you do that, you'll have the limit as h goes to 0. You can't use direct substitution yet because it would cause division by, well, 0. And you're going to take your function, which was x minus x cubed, and you're going to plug in 2 plus h. So you have 2 plus h minus 2 plus h cubed. And then you're subtract off f evaluated at 2, which we already know is negative 6. We said it in a previous problem, so that's why I know. And now I get to do algebra. It's going to be the limit as h approaches 0. Probably the hardest thing about this is just keeping track of everything. This is positive 6 on the back end. I'm going to add it to the 2 up front to become an 8 plus h minus, and then I'm going to cube out that I'm going to multiply out that 2 plus h cubed. Again, prerequisite from pre-calculus is Pascal's triangle or the binomial expansion, whichever you prefer. So this is going to be 8 plus 12 h plus, I'm just doing this very quickly in my head, 2 times 3 is 6, h squared, and then plus h cubed. Gosh, I hope that's right. I did that kind of quickly in my head. So, but I think that's right. 4 and 2. Yep. Okay. If you don't know how I did that, again, you need to look up. I don't have a video on Pascal's triangle. I will eventually. But at this point, this semester, I haven't reached that. So I haven't canned those lectures. But when I do, you're more than welcome to look at mine. It'll be a bit too late at that point, I suppose. Or you can look up somebody else's videos. Anyhow, the 8s will cancel. And the rest is just arithmetic. So let's go ahead and do that. It's algebra. H minus 12h is a negative 11h. And then distribute the negative through. We have a negative 6h squared and negative h cubed. And obviously, h will factor out of all of those. However, I'm a little too lazy as a mathematician. So I just cancel out a power of h in each of those cases. And now I know I can use direct substitution. So I will go ahead and do that. Direct substitution. And by the way, I do want to mention here, I'm going to write this in red. When you use direct substitution, you're no longer using a limit. So don't do that. I see so many students do that. Once you use direct substitution, that limit is gone. You have evaluated the limit. You have now obliterated it. So as h approaches 0, I have a negative 11 minus 6 times 0 minus 0. So it's just a negative 11. In either case, we found that the derivative at 2 is negative 11. It's derivative at 2 right there. All right, so I hope that at least that kind of opens your mind to finding the derivative at a point. It's actually not a terrible process, and you have options. Just remember, pre-calculus, prerequisite.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.